Welcome to this lecture. Alright, so before we enter into the mole concept or how to calculate moles, we need to know how to calculate the relative molecular masses of every compound. Alright, because we are going to meet the similar compounds within a given or reactions. Alright, so we say that the relative molecular mass of a substance is calculated by taking the sum of the relative or atomic masses of the total number of constituent atoms in the molecule of the substance. So for instance here, remember that for every hot atom we have 8 relative atomic mass. So let's assume we have been given the relative atomic mass of H to be 1.0 and that of alright, so these are the given relative atomic masses. So the relative atomic mass for hydrogen is 1, that of carbon is 12, oxygen is 16, sulfur is 32, and nitrogen is 14. Alright, so remember, if we are to calculate the molecular mass of every compound, we look at the number of constituent atoms present. So here we have hydrogen. So let's see, for I, which is the hydrogen H2, remember that it is 2 atoms of hydrogens present here. So if we are to find the molecular mass of the molecular mass of hydrogen, we have to multiply these 2 by 8 relative atomic mass, which will be 2 times 1, and which will give us 2. So the relative molecular mass for this hydrogen is 2. So we move on to II, whereby we have H2SO4. Alright, so in calculating this, we also look at the constituent atoms present. We have 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. So each of the atoms will be multiplied by their relative atomic masses, right? So here, if we are to work for the relative molecular mass of H2SO4, this is going to give us 2 hydrogens are here, so 2 times the relative mass of hydrogen, which is 1, then plus we need to sum, plus we have only one atom of sulfur here, so we have 1 times 8 relative atomic mass, 32, okay, because it is given here, and then plus 4 times the relative atomic mass of oxygen, which is 16, and this is going to give us, this is 2 plus 32 plus 4 times this is going to give us 60 or 56. Alright, 64. So if you add this is going to give us 98. So that is it. So it means the molecular mass of H2SO4 is going to give us 98 here. Alright, so let's solve the other one, the third one, which is C6H12O6. Alright, so the relative molecular mass of C6H12O6 is going to give us, we have 6 atoms of carbon. That means this 6 will be multiplied by the relative mass of carbon. That is 6 times 12, then plus 12 times the relative mass of hydrogen, 1, and then plus 6 times what? The relative mass of what? Oxygen, which is 16. Alright, and then this is going to give us we have this is 72 here plus 12 plus what? 60 plus 90 what? 6. Alright, so summing all these up, it's going to give us 180. So this is the molecular mass of the compound. Alright, so we work for the last one, which is IV, that is the anhydride compound, as Na2CO3.10H2O. Alright, so that means 2 atoms of what? Sodium. So we multiply 2 by the atomic relative mass of what? Sodium. Sorry, yeah. So this is not nitrogen. Sodium instead of nitrogen. So that of sodium is 23 here. Alright, so here we multiply these 2 by the 23, which is 2 times 23, and plus 1 hot carbon here, that is carbon is also what? 12, and then plus 3 times what? This oxygen here, 16. Alright, plus 10 times, because this 10 is multiplying all these ones, we have 10 times what? 2 times 1 plus how many here? 16. Alright, and then this is going to give us what? This is 46 plus 12 plus what? 48 here, and then plus all this is 18 times 10 is going to give us 180. Alright, so summing all this up, we are going to end up with 280. So in calculating for the relative or molecular masses, you just sum up or multiply the number of constituent atoms by their respective masses, and then sum up them. Alright, so I would like to end this video here. In the next video, we are going to move on to the mole as a unit. So don't forget to subscribe to this video channel for more other videos. Thanks.